Right, so quiz 11, our quiz for today, focused on utilizing our properties of logarithms, which we learned about in our last class. Our first part for our first question, we were asked to expand the following. We wanted to rewrite ln of 7r times 11st in, again, our expanded form. What do we know about the relationship between multiplication and addition versus there's a relationship between division and good. So when we expand this out, we can first expand it into just our natural log of 7r plus our natural log of 11st. But if you notice, we have a lot of multiplication that's taking place. We have another multiplication over here, and over here. So we can further expand this. So fully expanded form, we get our natural log of 7 plus natural log of r plus natural log of 11 plus natural log of s plus natural log of t. If you wanted to combine the 7 and 11 and make that natural log of 77, you could. That's fine, but you didn't have to. So you got what I got. You would have received full credit for this question. Any questions? No. Okay. Part B is the opposite. We want to now deal with not what?
So what I did was
Yeah.
I kind of like grouped mine. I didn't group mine together, but I made sure it was like that. But I put like parentheses around each other.
That's fine.
Okay.
Yeah, you get full credit. So yeah, part B is a condensing problem. And so we're given our 5 ln of B plus ln of C plus ln of 4 minus A over 2. This can be rewritten as what? Yeah. That way we can utilize our power rule. Bring that 1/2 to the front as an exponent. And we can utilize power rule here as well. So let's utilize power rule in both cases, and we end up with ln of b to the 5th plus our ln of c plus ln of 4 minus a to the 1/2 power. That's the same as what? Yeah, just the square root. So we can rewrite this as just the square root of 4 minus a. And then we can combine, again, addition is the same as multiplication. Then we can combine it one last time. So we get our final results to be natural log of b to the 5th times c times our square root of 4 minus a. Yes.
Question, right? So
Yeah.
I got the 1/2 in the thing. What I did was I separated first out of 4 minus L and A, and then I did that's like how many points off would I?
Yeah, you realized your mistake, right?
Yeah.
Yeah. 4-point question. Anywhere between like 1 to 2 points. Probably 1 point. Yeah. Because you got everything else right.
Yeah, it was that like
The minus, he thought it was division, right? Yeah. Leo?
What if I didn't change it to the square root?
If you didn't change it to the square root, I wouldn't take points off, yeah. Yeah. Reem? Guys, I can't hear. Yeah. Order doesn't matter. Yeah, usually you should put the highest degree first, but I'm not as picky in this example because all of the bases are different variables. If the bases were the same, then you would want it in ascending or descending order. So highest degree first and then everything that follows. But yeah, here I'm not too picky. Yeah. I feel like there's a question, either Christine or Alvin. None of you guys had your hands raised, no? Okay. All right, let's move on to the back page, where in question 2, we wanted to utilize our change of base formula. Wow, I really missed teaching on the iPad. You just have so many colors. So change of base formula. Our general is log base little b of a is the same as the log base of any real number, except 0, or 1, of big A all over log base n of little b. So using this, we want to change log base 3 of 21 to a quotient of natural logarithms, which is our whole ln, which is what? Log base. Natural log is e. Yeah. So log base 3 of 21 is the same as just log base e of 21 divided by log base e of 3. But we know log base e is just ln, so we can rewrite this as just ln of 21 divided by ln of 3. And we're done. Questions? Yeah. For a question like this, yeah, that's fine because not a lot of work is required. Yeah. Okay. And then finally, we have our last question, which was a proof question. We wanted to show that that left-hand side is indeed equal to the right-hand side. And so anytime you're asked to show, you want to keep one side constant. So if this is our left-hand side and this is our right-hand side, and you're also given the fact that our f of x is equal to log base a of x, then the manipulation that's going to be able to take place here is really honing in on that left-hand side. So we are going to change up that left-hand side to make it look like our right-hand side. We're not going to do anything to our right side. That's staying exactly the same all the way up to the end. So honestly, I'm just going to rewrite that right-hand side for the last part. Okay. That left-hand side we can manipulate. Our f of x plus h is what, Rahik? What is our f of x plus h? Doesn't even know I'm talking to him. He's having a side conversation. Can you tell me what f of x plus h is?
On log of a.
Yeah,
X plus h.
good. And then Rakin, what about f of x? I think that's what I'll do from now on. Anytime I hear people talking, I'll just call them out and they'll help teach the class with me.
Oh, it's not okay.
No one's gonna talk now. Log of a x. Good. All over h. Okay. So now let's utilize our properties of logarithms, and subtraction is paired with exactly. So that blue and yellow can be transformed into log base a of, in parentheses, x plus h all over. Yeah, x. Good. And this is all going to be divided by h. Now, everything being divided by h, can we rewrite that? Because that's a constant, right? Eden, what can that be rewritten as? Exactly. Can rewrite that as 1 over h times our log base a of x plus h over x. And then that coefficient now in the front, we can utilize our power rule and bring it into a what? Exactly. Nice job, Javier. When we bring it into an exponent, we're getting closer and closer to what that right-hand side looks like. So we once again get that log base a of x plus h all over x, now raised to the 1 over h power. And we're so close. The only thing that's different is what we have inside those parentheses. We want to separate that into our two separate fractions. And so x over x is just 1. And then h over x is the same as exactly. So we finally arrive at log base a of 1 plus h over x raised to the 1 over h. And is that indeed equal to that right-hand side? Yes. So we've completed the proof and thus completed the problem. Any questions on this last question or just on the quiz in general? Bruce?
Can you explain again how you remove the x from the equation, the x over x?
The fraction part?
Yeah.
Yeah. So we have x plus h over x. You can separate this into two separate fractions. Think about it as 5 plus 1 over 3. Isn't this the same as 5/3 plus 1/3, which is just 6/3, which is just 2? Yeah, so this is the same as x over x plus h over x, and x over x is 1 plus h over x. Strutha?
So anytime you have like kind of like a problem like that, right, where like you have like the log algorithm, it's like over another like variable. It's the same thing as the coefficient is essentially the fraction.
Yeah, exactly. Yep. Because if your denominator is a numerical value, then yeah, you can bring it straight in front.
And then you
Actually,
can-
even if it's not a numerical value, even if it was like all over hx, you can bring that in front and
after
then
that,
make it
you
an
can-
exponent.
You just bring it over to like the exponent.
Yeah. Exactly. I feel like there was another question over here, or I answered it. No. Okay.